Next we'll do the reactor. Notice how the picture is drawn on the screen in a fairly slow way compared to today. Chemical species that entered are reacted and made into other species which leave. Sometimes all the entering chemicals are not reacted. We speak of a reactor conversion or conversion per pass. If 40% of the key chemical reacts, the conversion per pass is 40%. The reactor is a unit where the inlet components are changed before leaving in the outlet stream. In this lesson, only a single reaction is considered, and the reaction is equimolar, large going to small. The inlet has 10 large markers. The reactor converts 40% of the large markers to small ones. If we let R be the amount reacting, then L1 minus R is equal to L2. In other words, the large coming in on stream 1 minus those reacted equals the large leaving stream 2, in stream 2. If 1 mole of S is made for each mole of L reacting, the mass balance for S is S1, however many S are coming in stream 1, plus those formed in the reactor equals S2. How many large are changed to small? For 40% conversion, it would be 4. How many small markers aren't changed to small? I'm sorry, it was how many large markers aren't changed to small. Since 10 came in and 4 reacted, there must be 6. That corresponds to a chemical reaction. Large going to small with a 40% conversion per pass. Notice that of what came in, 10, 4 or 40% reacted, leaving 6 of the original. Now we'll work another problem. Take 10 large and 5 small in the inlet with a conversion per pass of 30%. How many large markers are changed? 30% of the large ones, so that's 30% of 10, or 3. How many large markers are unchanged? So that's 7. And how many large markers are input? That's 10. And so how many large markers are output? That's 7. How many small markers were input? That's 5. How many small markers were output? Well, there were 5 that came in and 3 made, so there were 8 going out. How many markers were input? 10 plus 5 is 15. How many markers were output? 7 plus 8 is 15. And that completes the reactor.